Compounds made out of just two elements are called binary compounds. These compounds can be split into two groups: compounds made out of metal and nonmetal, and compounds made out of two nonmetals. Metal and nonmetal compounds are also known as ionic compounds. Nonmetal and nonmetal compounds are also known as covalent compounds. Ionic compounds can be split into two groups: ionic compounds with metals coming from group 1, 2, or 13, and ionic compounds with metals coming from groups 3 through 12. For our convenience, we will call ionic compounds that contain metals from groups 1, 2, and 13 type 1 compounds. Ionic compounds that contain transitional metals will be called type 2, and covalent binary compounds will be called type 3. Type 1 binary compounds: metals from group 1, 2, or 13, and a nonmetal. Here is the compound. There are two elements, sodium and chlorine. We will name them metal first and nonmetal second, and change the ending of the nonmetal to IDE. So the name of this compound, sodium chloride. Another compound made out of calcium and fluorine. So calcium fluoride. Magnesium and sulfur as an ionic compound will be called magnesium sulfide. Aluminum and oxygen as an ionic compound will be called aluminum oxide. Calcium and sulfur, calcium sulfide. Sodium and phosphorus will be ionic compound of sodium phosphide. Rubidium and bromine, rubidium bromide. To correctly write the formula of ionic compound, we need to keep in mind the following. Atoms of group number 1 become ions with the charge positive 1. Atoms of group number 2 become ions with the charge positive 2. Atoms of group 13 become ions with the charge of positive 3. Now nonmetals. Atoms of group 17, when become ions, gain charge of negative 1. Atoms of group 16 will have charge of negative 2 as ions. Atoms of group 15 will have a charge of negative 3 as ions. Keep this information close because we're going to need it to correctly convert names into correct formulas of ionic compounds. Magnesium fluoride. Magnesium would have a charge of positive 2 because it's ion of element from group number 2. Charge of fluoride ion will be negative 1 because it is ion of element from group 17. Final formula of a compound should have an overall charge of 0. So we are putting subscript number 2 after fluoride ion to indicate that there are 2 of them to every ion of magnesium. Potassium chloride. Potassium would have a charge of positive 1. Chloride ion would have a charge of negative 1. This compound is electronically neutral. No need for adjustments. Aluminum oxide. Aluminum would have a charge of positive 3 as an ion because it is element from group 13. Oxygen would have a charge of negative 2. It takes 2 aluminum ions and 3 oxygen ions to make up an electronically neutral compound. Strontium iodide. Strontium would have a charge of positive 2. Iodide would have a charge of negative 1. It would take 2 iodide ions to cancel the charge of strontium. Final formula of a ionic compound must be electronically neutral. Strontium chloride. Strontium will have a charge of positive 2. Chloride ion will have a charge of negative 1. 2 chloride ions are needed to cancel out charge of the strontium. Sodium iodide. Sodium would have a charge of positive 1. Iodide has a charge of negative 1. This formula is electronically neutral. There is no need for adjustment. Aluminum sulfide. Aluminum would have a charge of positive 3. Sulfide ion will have a charge of negative 2. The formula must be electronically neutral. Calcium bromide. Calcium element group number 2, its ion will be having charge of positive 2. Bromide ion will be having charge of negative 1. It takes 2 bromide ions to cancel out charge of the calcium. Type 2 binary compounds are ionic compounds made of metal and nonmetal. But here is an important detail. Metals of type 2 compounds come from groups 3 through 12. They are transitional metals. Transitional metals are less predictable in their charge, so the charge of those metals in a compound is not detected from its position on the periodic table but calculated from the formula of a compound and reported in the name. For example, there are 2 iron oxides on this page. Each compound is electronically neutral. Oxygen as an ion has a charge of negative 2. That means that the ion of iron next to it will have a charge of positive 2. Charge of the metals reported in the name of the compound as a Roman numeral placed after the name of the metal. So this compound is called iron 2 oxide. Compound on the right also contains oxygen with its charge of -2. Iron next to it must have the charge of +3 to make this compound overall electronically neutral. So this compound will be called iron 3 oxide. Since the charge of transitional metals may vary, we must calculate it from the given formulas and report it in the name of the compound. To correctly name these compounds, we must calculate the charge of nickel and report it in the name. Let's consider compound on the left. Fluoride ion has a charge of -1. Since there are two of them in the compound, nickel standing next to them must be having charge of +2. Name of this compound then will be nickel 2 fluoride. Compound on the right also contains fluoride ion with its charge of -1. Since there are three of them in the compound, nickel next to them must have a charge of +3 to bring the overall charge of the compound to 0. Name of this compound will be nickel 3 fluoride. This compound is made of copper and chloride ions. Chloride ion would have a charge of -1. There are two of chloride ions here, which means that this copper must carry a charge of +2. Name of this compound is copper 2 chloride. Another compound. Well, sulfide ion would have a charge of -2, meaning that cobalt in this compound has a charge of +3. So correct name for this compound would be cobalt 3 sulfide. We've learned how to name type 2 compounds. Now let's practice writing formulas from the names. Iron 3 bromide. Symbols of iron and bromide. Now charges. Iron has a charge of +3. We see it from the name of the compound. And charge of the bromide ion is -1 because it is an element from group 17. To make this compound electronically neutral, we would need 3 bromide ions. Now formula is complete. Copper 2 chloride. First, writing symbols of the ions. Second, assigning charges. Copper +2, it is known from the name of the compound. Chloride ion is charged -1. It is known from the position of the element on the periodic table. To make this formula electronically neutral, we have to have 2 chloride ions. Nickel 2 sulfide. First, writing symbols of the ions. Second, assigning charges. Nickel +2, known from the name of the compound. Sulfur -2, known from the position of the element on the periodic table. This formula is electronically neutral. No adjustments are needed. Nickel 3 iodide. First, writing the symbols of the ions. Second, assigning charges. Nickel is +3, which is known from the name of the compound. Iodide is -1, known from the position of the element on the periodic table. 3 iodide ions are needed to make this formula electronically neutral. Type 3. Binary covalent compounds. Covalent compounds do not have charges to guide us, so we have to describe molecule with the help of prefixes. This compound contains 2 atoms of nitrogen, di-nitrogen, and 5 atoms of oxygen, penta-oxygen, or more specifically pentaoxide. The ending IDE is important to indicate that this is a binary compound. You may notice we're describing the molecule in a zigzag fashion. Following the zigzag, disulfur trioxide. Don't forget the ending IDE. Dinitrogen monoxide. Once again, don't forget the ending. And once again, following the zigzag from the number to the element, to the second number and then to the element. Tetraphosphorus decaoxide. Prefix mono has additional rules to follow. When it applies to a first element in a binary compound, it must be dropped. For example, this compound is, technically speaking, monocarbon dioxide. However, we call it carbon dioxide because we dropped prefix mono since it applies to the first element in the compound. This compound is mononitrogen dioxide, but we drop prefix mono for the nitrogen because it is the first element in the compound. Interestingly, we are not allowed to drop prefix mono if it applies to the second element in the compound. For example, this compound is called dinitrogen monoxide, and we are not allowed to drop prefix mono before the word oxide. Carbon monoxide represents combination of both of these rules. Prefix mono dropped before first element and kept before second. Now let's go from name to the formula. Carbon tetrachloride, 1 carbon, 4 chlorines. Sulfur trioxide, 1 sulfur, 3 oxygens. Dinitrogen pentoxide, 2 nitrogens and 5 oxygens.